This video is brought to you by Academy of Higher Learning. Please visit our website to view more educational videos, such as this one. In this video, hello and welcome to today's video on physics-kinematic motion. In this video, I'll be doing 2D problems and introducing the concept of relative motion. And also, just on a side note, I've added the kinematic videos of 1D problem in the description below, so check it out if you haven't. So let's start with the 2D problem. Question 1. So we have a scenario such as this, and it's telling us a ball at a 4 meters height is traveling at 20 meters per second squared. Will it clear the net that's 15 meters away? And if in part B, it tells us how much will it clear it by, if it does clear, that is. So in this, we have to take notes of a few things. First, there's gravity involved, which is 9.8 meters per second squared. The second thing we need to take into account is that the projectile motion is going to be somewhat quadratic. So it's going to be something like this. Why? Because we have gravity. Remember, recall one of the kinematic equation, which is delta d equals v1t plus 1/2 at squared. This part makes it quadratic. And the last thing we need to take into account is that the velocity in the vx direction is independent from the velocity in the y direction. These two are dependent based on time. So now we can solve the question. I'm just going to draw the x, y's. So this is positive x, this is positive y. And next, will it clear the net? So there are many ways we can do it, like we can compare the times, or we can compare the time and then solve for the x displacement and compare that with 15 meters, or vice versa, solve for time and compare and find the displacement in the y and compare it with 4 meters. So the way I'm going to do it is by comparing the times that it takes for the ball to reach 1 meter and the time it takes for the ball to reach 15 meters. So let's do that. So the equation I'll be using, delta dy equals this one, basically v1y t plus 1/2 ay t squared. v1y, there is none, so that's 0. Delta dy, well, it's the displacement from this point to that point, and that's going to be -3. So the way you can do it is by 1 minus 4 equals 1/2 times minus 9.8 t squared, and that's -3. If you solve for t, you're going to get well, you'll get delta t equals, or t just equals 0.78 seconds. And the other thing, next I'm gonna find the time that it takes for the ball to travel 15 meters horizontally. So delta dx equals v1x plus 1/2 ax t squared. This is 0. I think I forgot the t here. So 15. If this point is 0, this point is 15. So it'll just be 15 minus 0. And v1 is 20 times t, and we get t equals 0.75 seconds. So since this is greater than that, now it tells us that at 0.78 seconds, the ball is somewhere like in this area. Alright. Oh, sorry, the ball at 0.78 seconds is in this area. At 0.75 seconds, it tells us the ball is right here. So basically, will it clear the net? Yes, because the ball reaches the height of 0.78 reaches a displacement of -3 after it reaches 15 meters in horizontal. So it will reach this first before it reaches that displacement of -3. So to answer to the part A, it's going to be yes. How much will it clear it by? Well, we just put this time into this equation and solve for the displacement. So let's just make this d1, and whatever the height is going to be, I'm just going to put a point here, d2. So we're going to have delta d, once again, y equals v1y t plus 1/2 ay t squared. delta d will be d2 minus d1. So d2 is some random value. Minus d1, I'm just going to bring it to the other side. This is 0. So we're going to have 1 half minus 9.8, 0. 0.75 we're using this time because that's when the ball is right here and somewhere around here. Squared plus d1, which is 4. And we get d2 equals 1.24 meters. So the height from here to here is 1.24 meters. How much did it clear the net by, which is 1 meter tall, is going to be 1.24 minus 1, and that's going to be 0.24 meters. So that's question 1. Pretty simple. And yeah, just keep in mind that you can solve x. You don't need to take like Vx and Vy are independent. Question number 2. Alright, if the ball is launched from a platform with 40 meters per second at an angle of 60 degrees, the velocity is high enough that the ball will land at 20 meters elevated platform. So find the stuff. Alright, so we know this is 60 degrees and the ball trajectory is going to be something like this. And it's guaranteed that it will land here on a 20 meter platform. So part A, find the flight time. So the way you can do that is by using one of the kinematic equation that we've been using, the delta dy equals v1y t plus 1 half ay t squared. Let's just say this point is 0, 0, or d1 x, d1 y, and this point is d2x and d2y. So delta dy would be d2y minus d1y, and so basically delta dy equals, because this is 0, therefore it equals d2y. So let's just stick with that. v1y is going to be 40, and we have to take into account the angle. So it's going to be 40 sine 60 plus 1 half minus 9.8 t squared. And if we solve for t, we're going to get two answers, 0.63 or 0.65 or 644 seconds. The right answer is this one because well, the displacement is going to be, oh wait, delta I forgot something. This is going to be 20 because delta d2y is 20 meters, we know that. So if we solve for t, we're going to get 0.63 seconds or 6.44 seconds. And this is because the displacement in the y direction is going to be 20 twice. Once right here, and the other time when it lands. And we want the time when it lands, so that's going to be 6.4 seconds. Find the range. Just put it into this same equation, but with x components. So it'll be delta dx equals v1x t plus, well, there's no acceleration, so I'm going to skip that. And once again, delta dx equals d2x, so we can just stick with that. And v1x is 40 cos 60 times 6.44 when it lands, and we get the displacement of 128.8 meters. So this is 6.44, this is 128.8. Find the velocity when it lands, wrong word, not ends, but lands. And the velocity when it lands, we're going to be using this equation, v2 equals v1 plus at. So let's solve for both components of y and dx. Let's do x first because it's pretty simple. v2x equals v1x plus ax t. There is no acceleration in the x, so that's 0. So therefore v2x is going to be 20 meters. 20 meters per second, or 40 sine cos 60. Let's go for solve for v2y. v2y equals v1y plus ayt. It's going to be 40 sine 60 minus 9.8, 6.44. And we got v2y equals minus 28.4. So let's draw a simple graph to illustrate the velocity, and it's going to be something like this: 20 going right or east, whatever you want to call, however you want to say it, and it's going to be minus 28 down, or 28.4, and this will give us the hypotenuse will give us the final velocity, and this is theta. We need to find theta too. So v2y, hopefully, v2, my bad, is just like v2x squared plus v2y squared. So 20 squared plus 28.4 squared. Hopefully you guys know about Pythagoras theorem, and it's going to give us an answer of 29.1 meters per second. And then we need to find theta, which is going to be 10 opposite 28.4 over adjacent, and we get theta equals 54.9 degrees. Let's just put this together, and therefore v2 equals 29.1 meters per second, right or east, however you want to say it, 54.9 down or south, either works. So that's part C, and last part is find the maximum height. So the maximum height is going to be when basically a turning point, which you're going to learn in calculus later on, if you've taken it, you'll probably know about it. So it's going to be, the trajectory right now is something like this. So the maximum height is going to be right here, and at the maximum height, v2y is going to be changing direction from going up to down, and at the maximum height it's going to be 0. Once again, it's a turning point, that's why. On the left side, once again it's going up because it's positive, and on the right side it's negative, and that's why it's going down. So we can use this equation: v2 squared equals v1 squared plus 2a delta d, and this is y. So v2 squared is 0 because of this point, so that's gone. What's v1 squared plus 2a delta d? We know the values of all the just solve for delta dy, and we get delta dy equals, if you put the numbers in, I don't have enough space to do that, you get 122 meters. So that's the maximum height, 122 meters. Now that's done, that's taken care of. Let's go to the next topic, relative motion. Oh, that's a bad line. Okay, so relative motion is when the laws of physics are applied to a certain reference frame or perspective that is moving at a constant velocity. Believe it or not, we've been using this concept the entire time, but in the example problem 1 and 2, the relative motion, the constant was 0 meters per second, so it didn't really matter. So that's why we didn't take it into account. So let's start with an example. It's always a great way to get a concept in your head. You're a good driver driving at 100 kilometers per hour. Your friend is a bad driver and they are driving at 120 kilometers per hour. What is the relative motion, or what is the velocity? That's wrong. Velocity of a person standing still and your friend according to your reference frame. So in your reference frame, the constant velocity is 100 kilometers per hour. So there are several reference frames which you can view this in, but we are viewing this in your reference frame. So once again, in your reference frame, the constant velocity is 100 kilometers per hour, and anyone moving at the same velocity to you will be like they're moving at 0 kilometers per hour, and all the other velocities are with respect to that. So your friend's velocity with respect to your reference frame is 20 kilometers per hour because he's going 20 kilometers faster than you, and the person standing still has a velocity of minus 100 kilometers per hour because he's going minus 100 kilometers slower than you, or 100 kilometers slower than you. Next, let's do a notation. Let's do another example actually. Um, Say there's a river. Yeah, and the stream has a velocity. Let's just say WG, and there's a boat, terrible boat, that has a velocity, and the ground has a velocity. So there are a bunch of velocities. There are like three velocities actually in this case. There's a velocity of the boat with respect to the ground. There's a velocity of the boat with respect to the water. And last but not least, there's the velocity of the water with respect to the ground. And if you've taken vectors, you know that because of these two, this is equal. Like you can equate these two sides. And because the water, the W's will cancel out, giving you WBG equals WBG. Velocity of water boat with respect to the ground with the velocity of the boat with respect to the ground. So let's do another example. You're driving at 30 meters per second east. Your friend is driving at 40 meters per second west. And what is your velocity with respect to your friends? So let's just say east is positive, west is negative, and let's use the same concept here. So we want to find your velocity with respect to your friend. So on the right side we have W, your velocity with respect to the ground, equals your velocity with respect to your friends, let's just say F is your friend, plus your friend's velocity with respect to the ground. So we know this. Your velocity with respect to the ground is 30 meters per second east. We want to find this, question mark, WF. Make sure you don't turn it around. If it's switched around, it'll mean they're a totally different thing. Plus, your friend's velocity with respect to the ground is minus 40. Bring this to the other side, and you get your velocity with respect to your friend will be 70 meters per second. And another way of seeing this is, say you're going on a highway, it's two-lane, you're going at 100 kilometers per hour, and some other guy's going at 100 kilometers the opposite way. If you look at their car, it would seem that they're going much faster than 100 kilometers per hour, and that's because of relative motion. In your reference frame, you're going on 100 kilometers, but compared to their velocity with respect to your reference frame is 200 kilometers per hour. That's why they seem much faster. But in reality, they're going actually at the same speed as you. So that's basically the end of the video. Yep. So visit our website, and if you have any questions or comments on improvement of us improving the learning experience, feel free to comment below. And visit our website to view more videos like this. Well, thank you for watching. Take care. Later.